Hello, welcome back. Today, we want to talk about the distance and midpoint formulas, and specifically how to use them. So our goals then are to be able to find the distance between 2 points in space or in a plane using the distance formula. Then also for a similar pair of points, be able to find the midpoint in the line segment between 2 points using the midpoint formula. So first, let's take a look at the distance formula on the left. So if we have 2 points, we just call them A and B. And we could just call the first one, just for convenience, x1, y1. Just call them at point 1. And B is point 2, so we have x2 and y2. And what the distance formula is, it just says if we square the differences between the x coordinates and the y coordinates and then add those together and take the square root, it gives the distance between those 2 points. Let's come over here to the right then. And take a look at how this works. What we're going to do then is explain how it works and then do a couple of quick examples. So let's imagine we're in the XY plane, and where this is our x-axis, this is our y-axis. Let's say we have 2 points. Once again, we're just going to call them x1 and y1 has coordinates x1 and y1, and this one has coordinates x2 and y2. Now, they could be anywhere in the plane, but just easier to prove in the first quadrant. And so what we're curious about then is, what's this distance between these 2 points? How long is that? So what the distance formula does is basically think about this right here. Let's think about this point here on the x-axis is x1, and here this is x2. And in terms of y's, on the y-axis, this is where y1 is, and on above on the y-axis is where y2 is. Now, what the distance formula does is basically we're taking this distance right here between these two, and this distance is essentially x2 minus x1. For example, if this was 5 and this was 2, know the distance between 5 and 2 is 3. It's 5 minus 2 is 3. Okay. And the same way, this distance over here, in the same way, this is y2 minus y1. Okay. Now, what we want to do then is actually let's think about a triangle, specifically a right triangle, where this length here is this x2 minus x1, and this length on this side, the vertical length, is y2 minus y1. This is a right triangle. And so basically what we have then is we have a right triangle. We can essentially use the Pythagorean theorem, if you're familiar with that. Remember, the Pythagorean theorem is for right triangles. Oops, let me do a better job than that. So if you have a right triangle, the Pythagorean theorem, though, is only for right triangles. And so if you call this distance here C, though it doesn't matter, call this A and this B, what the Pythagorean theorem says for a right triangle is that C squared, the hypotenuse, square of the hypotenuse, is equal to the squares of the lengths of the other two sides. Okay, so we're going to do that for our example here. All right, and remember our lengths, this length here, this bottom length is x2 minus x1. This vertical length is y2 minus y1. And then the hypotenuse is this distance here. Let's call this d. So what we have then is d squared, the hypotenuse squared, is equal to x2 minus x1 squared plus y2 minus y1 squared. And then, of course, we simply take the square root of that. Now, in general, taking the square root of both sides, you'd also have to consider a negative value. But since distance is always positive, we're just going to look at the positive value. And so it's just the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared, okay, which is our distance formula. That's where it comes from. And once again, in general, if you essentially think of taking the square root of both sides, take in general terms, this would be plus or minus, but since this is always positive, we just take the plus value. Okay, so that's where it comes from. And once again, we did this in the first quadrant. This will work for any 2 points, anywhere. Okay, this gives the distance between them just using this idea of Pythagorean theorem. Now, let's look at an example, or a couple examples. Okay, so we want to find the distance between 2 points. And let's say, number one, let's say our 2 points, we have these 2 points. So we have -2 and 3, and then we have 3 and -6. So remember, this point here is actually being quadrant 2, and this point then is actually going to be in quadrant 4. Now, it doesn't matter which one we call x1, y1. Actually, we'll do this example both ways to show this. So let's call this one x1, y1. Let's call this our first point. And this then is x2, y2. That doesn't matter as long as we're consistent. Okay, so then the distance then, by the formula, if we do x2 minus x1, okay, so we do this x minus this x. So this is going to be 3. Now here we also have to be really careful with our signs. Okay, we're subtracting. This negative here is part of the formula, but here this term is negative, so you need to make sure we include that. So we're subtracting a -2, then we're going to square that. And then the y's, now here's where we have to be consistent. So, well, it really doesn't matter as long as we're correct the sign. So y2 minus y1, and so we have -6, then minus, this minus is part of the formula, then 3. Then square that. Okay, then simplify. So if we subtract a negative, it becomes positive. This is become 3 plus 2 squared. Then plus, this is going to be -9 squared. Okay. Then we're going to have 5 squared, and then -9 squared. And if you square a negative, you get a positive. 9 squared or -9 squared is positive 81, and you get a positive no matter which way it happens. And then this is going to be then 5 squared is 25 plus 81. And let's see. And that's going to be 106. Now, that may or may not simplify. I'm not really going to worry about that, but let's also approximate it with a calculator, because as it is, that's not in most things if you ever have to use this, most of the time you're not going to do something, leave it like that. Well, that is the exact answer. And so just use your calculator. So let's just do 106 in the square root. And then that's approximately, and these little squiggly bars mean approximately, I'm going to do 2 decimal places, approximately 10.30. Okay, so that's the distance between those 2 points. So actually, let's go to Desmos. Desmos is a graphing website. Just go to dsmos.com, graphing calculator. Now, in this case, you don't actually have a line to plot, but that's okay. We can actually just plot points in Desmos, so we'll show you how to do that. So if I just plug in my points, so -2, 5, so -2, 3, rather, and all it says label, so it shows it. But let's go ahead and label it. Then let's come down here and do the other point, 3, -6. And also it asks me to label that. Yes, it shows it down here at the bottom. Let's also label it. So then imagine the line that goes between these 2 points, then that length then is approximately 10.3. Now, let's go back and take a look. Let's actually do this. We'll do this time. Let's do another example by doing the same example. This time, let's also show you that it doesn't matter what order I do these in. Let's start right here. So number 2, use the same points. So -2, 3, and then the other point was 3, -6. This time I'm going to call this one x2, y2, make this 0.2 because it doesn't matter, and make this one x1, y1, just to show you, just for more practice, and also show you that it doesn't matter which way you plug them in as long as you're careful with the signs. What's important is the difference between the x's and y's. So d, distance, is equal to the square root. And so if we do x2 minus x1, so it's going to be -2, then minus +3, then square that, plus, then 3, our y2, minus, remember this minus is part of the formula, then minus a -6 squared. One more parenthesis there. Okay, simplify that. And so that's going to be -5 squared plus 3 plus 6 squared. This bracket negative is going to be positive. And then that's going to be -5. Since we're squaring a negative becomes positive, it's going to be 25 plus 9 squared. As you see, we're going to get the same thing we did before. The square root of 25 plus 81. And then that's going to be the square root of 106, which is approximately 10.3. Okay, so as long as you do everything correctly, as long as you're careful with your signs, it doesn't matter which one we call our first point and our second point. Okay, that's the distance point formula and how to use it. All right, and one more thing I can say about our, if we imagined drawing a triangle, a right triangle between these points in the same way we did before, then that distance there would be the hypotenuse, and then that would give us the length of that side of the triangle. Okay, next let's talk about the midpoint formula. In a similar way, we're going to show where it comes from and then do a couple examples. Let's look over here to the left. It says the midpoint formula. So we have a line segment between 2 points. We call them A and B again. We call them the same way x1, y1, x2, y2 is given by this. So once again, let's draw this picture and kind of explain where this comes from. We'll draw some similar points like we did before. This time I think I might draw them like this. So this is our x1, y1, and then down here is our x2, y2. So we have a line between these 2 points. I already know how to find the distance between those 2 points. In this case, we're interested in the midpoint. So in the same way, let's draw on each axis where each point is. So this is x1, this is x2, this is y1, and this is y2. Now, what the formula does is basically, if we average, we find the average x value, and this point right here, which is going to be right in the middle, that's the average, is going to be x1 plus x2 over 2. Of course, that's the average of our x's. And the same thing we do here, for average the y values is going to be right in the middle. And so this then would be y1 plus y2 over 2. Or also you do y2 plus y1. Doesn't matter because as long as you're careful with the signs, you can add in any order. And once again, that's also the average y's. And so if you plot where these 2 points line up, then you get exactly the midpoint, which is x1 plus, make that a little better. Oops, I didn't want to do that. Hang on. Try that again. Having a little issues in my writing tool for some reason. Okay, be patient with me here. I'm having trouble with my writing tool. All right, so this then But anyway, this point in the middle is x1 plus x2 over 2 and y1 plus y2 over 2. Okay, and that then is our midpoint. For some reason, I can't seem to erase that point. Someone's going to be patient here with me. I'll get this figured out. There we go. Okay, so that then gives us our midpoint of this line segment in between these two. This is our midpoint. Okay, so that's where this comes from. Now, let's actually do a couple examples where I actually find the midpoint. Okay, so our first example, number 1, I think I'll just use the same 2 points we used before. So for our distance formula, so -2, 3, and for ourselves, we're supposed to find the midpoint of the line segment between, I'll say between these 2 points. Okay, and the second one is 3, -6. Okay, so once again, as the formula says, what we're doing is just going to average our x's and y's, and it's going to be a coordinate pair. So it's going to be what's going to call, it doesn't matter which one we call x1, y1, or x2, y2. Let's call this our first point. So it's going to be -2 plus 3 over 2 for x's, and then 3 plus a -6, or basically 3 minus 6 over 2. Okay, once again, -2 plus 3 over 2, averaging the x coordinates. Then 3 plus, I just put as 3 minus 6 over 2. And then if we just simplify that, that's going to be 1/2. And then the other point then is going to be -3 halves. Okay. Let's go back to Desmos. Let's take a look. Let's plug that point in. So -1/2 and -3 halves, and see if that looks like that's in the middle. So let's plot that point. We can also do fractions pretty easily in Desmos. So just do 1 and just do the division symbol where the plus sign is, and then do the right arrow to get out of the fraction. Then -3 halves. And once again, let's label it. And as you can see, if you think about the line that goes between those 2 points, looks like that is right in the middle, as we expect. So that's the midpoint. Okay, let's do one more example. Let's do one that's a little bit different. So if we know the endpoints of a line segment, like we did in this example, we can find the midpoint. Let's say we have this, number 2. Let's say we know we have an endpoint of a line segment is, let's say, 3, 1. And once again, it could be any point. Let's pick that endpoint is 3, 1. Then the midpoint of the line segment is, let's say, 4, 7. So what we're going to do then is find the other midpoint, find the other endpoint. This is kind of an application of the formula. I'm going to find the other endpoint. Okay, so first off, let's go back to Desmos and plot both these points. Now these, also like with other graphs of Desmos, I can actually, well, to turn those off, you also want to get rid of the labeling, just to clean things up. We can keep them on here if we want to use them later. Let's plot both of these points. So we have 3, 1, and also want to label it. And the other one is 4, 7. and also label that. Now, so what this is we're saying this is one endpoint, this is the midpoint. So where should the other endpoint be? And as we can guess, we go kind of similar distance. You just zoom out a bit. Looks like it should be maybe up here. Will that be around? Well, let's see. Let's zoom back in. Let's actually move this. We can also move this around. And so that should be probably around 512, something like that. I'm going to be exactly, but it looks like that's probably about right. So that gives us an idea. So if we get something that's really different from that, we probably did something wrong. Now let's explain how to find this thing. Okay, so once again, we're going to use this formula. So we know then let's use the midpoint formula. Okay, so know our midpoint, okay, is 4, 7. And if we use the formula, plug in what we know the formula, one of our points, it doesn't matter which one we call it, okay, one of it is going to be 3, 1. So look in our formula, we know one of our coordinates is 3. So let's just make this 3 plus, let's call the other one x, our unknown one, okay, over 2. Then same thing for the y's. So we know one of our endpoints is 1. So let's make this 1 plus y over 2. So if our unknown point is some xy, then just plug everything into our formula. We know the midpoint is this. We know one of our endpoints is 3. With the other endpoint, and the endpoint is says x coordinate 3 and y coordinate 1. We don't know the x and y's, but that's what we can find that. So what we can do then is now we have essentially two equations. Okay. Because we know that this is the x coordinate of our midpoint. So this has to equal 4. So we have 3 plus x over 4, over 2, rather, is equal to 4. And the other one then is that 1 plus y over 2 is equal to 7. Okay. So we just solve each one of these. And so multiply both sides by 2, top and bottom by 2. So the 2's cancel out here. We have 3 cancels out. Write that better. 3 plus x is equal to 8. And then subtract 3 from both sides. X is equal to 5. Okay. Do the same thing over here. Multiply both sides by 2 to get rid of the 2 in the denominator. Okay. These 2's cancel out. 1 plus y is equal to 14. And so then y, subtract 1 from both sides, y is equal to 13. So our guess is pretty close. It's actually going to be 513. So the other endpoint is 513. Okay. Now let's go back to Desmos and take a look at that, see if that makes sense. We already said we're pretty sure it does. Let's go ahead and label that one. So 513, label it. Yeah, that's right about where we guessed it. If you looked, those distances appear to be the same. Good. So that then is how we can actually use the midpoint formula then to find another one of our endpoints. And then you could also, if you wanted to, you could actually find the distance between these 2 points, or also distance formula, also using distance formula, find the distance between any 2 points, like between these 2 or between these 2. So let's kind of sum up what we've done. So what we've done is we learned both the distance and midpoint formula, where they come from, and then also how to use them to find distance between 2 points and to find the midpoint on a line. Thank you. Have a good day.